This video will demonstrate how to optimize the FLdigi QSK on write audio channel system. The idea is FLdigi will send out a stereo signal. The left side will be the normal CW waveform, however you have it set up. Here we have it 50% weight, dash it at 3, 5 millisecond rise and fall time using the Hanon raised cosine. So we've engaged the QSK on write audio channel. So we're using a Raspberry Pi and FLdigi. The FLdigi is using the Raspberry Pi's analog sound card, and it's using a stereo signal going out. So we have two circuits hooked to the end of that audio cable. One goes to the input here, this 8 ohm to 200 ohm transformer. It goes to this voltage doubler that keys a transistor that keys the rig, the CW jack. Another circuit on the right channel is going through the same sequence and storing up, keying a transistor that keys the push-to-talk jack. So we have two circuits. One goes to the push-to-talk jack on the K3, one goes to the CW jack on the K3. The idea behind this, and why I'm doing it, is that the K3 has much better QRQ CW timing when you use push-to-talk before you send the CW wave. So, but instead of having a foot pressing a foot switch or something like that just to turn on the push-to-talk, we're going to use FLdigi to do it. And you can set FLdigi, as you see I have this check marked here. You can tell it how soon before the CW wave and how long after the CW wave. Now on these settings right here, we're having 6 milliseconds before FLdigi sends out the CW on the left channel, but on the right channel we have -2. That means it's going to send 2 milliseconds before the CW wave ends. And that's just a matter of your rig and the timing of how your QSK works. The idea is we're trying to get as much receiver audio between elements or between words or however fast you want it to set, and for it to behave well. So right now I'm going to demonstrate the difference between using push-to-talk versus not using it. FLdigi, the Elecraft K3 and the K3S will shorten DITs when using full QSK. I'm using full QRQ plus mode on this K3S. So I'm going to send a DIT, and we're going to measure it on the scope here. And this is the side tone coming back into a sound card. This is how we're able to use this scope. So there's a DIT at 60 words a minute. Now I'm going to take the push-to-talk out of the picture. We're going to go over here to the rig and undo the circuit to the push-to-talk, and I'm going to send another DIT, and you'll see how it shortens it. So there we have a shortened DIT. Now I'm going to put it back on. And we'll do it again. And it should lengthen it back up where it should be. There it is. So that's quite a bit of chopping that's going on. So you're going to sound kind of light. But using this FLdigi QSK on the right side, you'll be able to counteract that. And one of the benefits of using it this way is you can push the K3S a little harder and go above 100 words a minute. And I've been able to, on mine here, it'll go up to 120 before it starts acting up and starts breaking up. So I thought that was a very significant finding, and that FLdigi provides a fantastic system in order to optimize and use the K3S to its fullest in its full QSK QRQ mode. So I'm going to send a file, and we're going to watch it on a couple scopes. Then I'm going to start raising it up, and I'll raise it up to 120. And you can evaluate how it's doing, and I'm going to turn the receiver noise back up. Right now the RF output's at 0, but I'm going to turn up the receiver noise. And we're going to send some CW, and then I'm just going to increase the speed so you can hear and watch the background between phrases, words, and letters according to how fast we're going. So I'll bring up the other scope. And here we go. So if you raise or you lower the amount of power going out the left channel, this is a dB minus 8 dB, so you can hear it sounds lighter. So that's one way to control your weight. So I'll leave it right there for now. And we'll go up to 70. And there we have it. Did a great job up to 120, and it doesn't matter after that. Just the K3 is just not built. I'll turn this RF gain down again. So the K3 is not built for anything above that. It's really not supposed to go over 100, but using FLdigi, you're able to. So using this circuit, or something like it, and I'll give you the link to this article, there's a lot of different circuits you can build. One advantage of this is by inputting how much power through the transformers into this circuit, you can vary the width of the, you can take some weight on or off by how much power goes in here. So that's a little bit of an advantage. And as you could hear, as we took FLdigi down to minus 8 dB, it made it lighter. So you can adjust it however you like. And of course, you can adjust the other weight settings. So this is weight by percentage, and this way is just a weight by time, equal time between dit and da. So I was just trimming a little bit of time off each time. And as you get faster, you need a little bit more power. So I had it to -1 at 120. And that seemed to perform very well. I didn't hear any audio glitches. And there was still receiver noise even at 120 between words and phrases. And on the K3S and the K3 in general, the side tone, the way it looks, is almost a perfect match to how the RF is going to look. And so it's a great way to test your rig. So that's why we're using the FLdigi's QSK on the right audio channel to provide the best keying possible for the K3S. Thanks for watching.